So I'm going to take, I guess, probably a slightly more academic perspective and particularly focusing on materials R&D. I've also have to say that we've had a long association with India. I've been here about 50 times in the last 10 years establishing collaborations with many partners across India. So I also reflect a little bit about, I guess, some of the things I see in terms of developing R&D in India as well. I guess we're all aware of the tension that exists, and it's been discussed quite widely about the drivers for an academic and against the needs for industry, in particular an innovative economy. And I think many countries around the world have tried to address this. I guess also this morning was discussed the issue of rankings. I think rankings of universities, of course, are driven by citations, high-impact publications, etc. So all these things, I guess, are driving us as academics to really focus on discovery science. And discovery science has a very important role. It's a very important role for training of the next generation of researchers, but also many of the breakthroughs in terms of actually what we do on a day-to-day basis have come from discovery science. But there is this interesting tension then about how do we do the discovery science on one hand and the shorter-term innovative type research on the other. I guess the Australian government, we follow the UK system quite widely, so whatever the UK does, we tend to do 5 years later. So one of the things governments like to do is like to measure things. And so the Australian government decided to measure research and came up with a very complex system of how we do this. It's largely a desktop system, again, based on the quality of a publication and then the citations it measures, etc., etc. And we were going to measure impact of the research, and that went in the too hard basket. So for the last 5 years, there have been various studies around government trying to measure, or trying to work out how do you measure impact. Is it patents? Well, not really, because anyone can make a patent. Is it revenue? Well, the thing is, often a big discovery might not have impact until 10 to 20 years later. So we're stuck with this measure, I have to say, in Australia. And of course, what happens now is academics are more and more driven to high-impact publications where you might get high citations. And so in some ways, the government, although it wants to make our research more useful, is putting up measures that actually make us tend to be more academic. Our own laboratory, it's a precinct. 10 years ago, we had only about 10 researchers. We now have about 250 researchers, and in the government measures, we still managed to get a 5, which is the highest score you can get in materials. But we obviously, in many ways, have ignored the government agenda and said, well, what we have to really do, being a relatively new university, is to develop a model where we can work both in the fundamental area but also in the innovation space. To do this, we've created a multidisciplinary research building, and as I think the colleagues have spoken before, you really do need to mix up the sciences. The chemists, the biologists, the mathematicians, the engineers, they're all in one building. And I guess for most innovation parks, you'll find one of the most dynamic parts of the innovation hub is a coffee shop, and we have a fantastic coffee shop. And what we're trying to do is find common languages. It's very easy to say we should put everyone together and they'll innovate. But trying to find a common language, a common understanding, and then trying to find the problems which are amenable to this are quite difficult tasks. We've gone to the stage further. In fact, we actually have a commercial-scale carbon fibre plant, which is an open access R&D facility. There's one at Oak Ridge, and we've got the second one in the world. So that's really going to the next stage and saying that for us, fibres and textiles and metals are our key foci. And so what we've done is we've gone and invested in a full-scale carbon fibre plant to allow us to do commercial-scale R&D with industry. What I want to emphasise here is about focus. Geelong, where we're based, is a textiles and automotive city, so metals and fibres are a natural match. We haven't done research on ceramics. We don't do research in other areas. And I think one of the challenges sometimes when I go around India is trying to find, and you are doing it, some cities have been shown as foci for manufacturing, say in Madras or Chennai, etc. And it really is saying, here is a natural advantage you have, how can we use that to grow our R&D capacity? As we said, composites are a strategic thing. We've even gone to the stage of having startup companies formed from student projects. So again, we've got this mixture where we have fundamental research in the building, spin-off companies in the building, and applied full-scale manufacturing facilities next door as well. So it's a sort of a, and we use this word ecosystem now, it's a unique manufacturing ecosystem. There are many examples around the world, this is only just one. Internationally, I think in manufacturing, you really have to be internationally engaged, and that's a real challenge, I think. These are some of our partnerships, and I guess you can see there's a strong focus on China. There's a reason for that. But there also is a strong focus on India as well, which I'll show on the next slide. But I guess if you do have this focus, we have a partnership with Terry in Delhi with a Centre for Nanobiotechnology, which has already grown from 0 to 25 people in a short period of time, and we've now run out of space to grow to the next stage of 50 people. And that was done by attracting global R&D funds. So they're obviously funding from DBT and DST in India, but also by having this partnership and offering a unique platform of agricultural biotechnology and nanotechnology from our Deakin, we're able to attract global R&D funds into India, and that's the theme of this conference, of course. We have a broad engagement with India, with a number of the IITs where we have meaningful research projects, but we also work with industry where we have PhDs based in industry but enrolled at Deakin. And I could talk to those who are interested about this afterwards, but it shows there's quite a broad spectrum of both industry and academic partners across India. In particular, in Delhi with Indian Oil, we have 5 PhDs, and they'll probably grow to 10 in the next 2 years, focusing on specific aspects, again, where there's complementarity of research interests. What's happening in manufacturing? Well, the world is really changing. We are going toward the 4th Industrial Revolution, and basically, conventional manufacturing as we know it now is being challenged, which is an interesting challenge for India because even conventional manufacturing lags behind most of the world in terms of its readiness for innovation and technical development. The conventional way of making a metal was you cast something, you shape it, you measure the properties, you look at the microstructure, then you go back and do it all again and again and again and again. It's great for academics because it keeps us employed for many, many years. But what's happening now is when we're working with Europeans is we try and use basically a biotechnology approach where we rapidly screen numerous alloys at the same time. So we might make 100 compositions at once. We'll work out some micro tests that measure some property very quickly, we'll rapidly screen, then we can make another 100 alloys straight away. This is really changing it. It's not based around papers, of course, it's based around really rapidly trying to get into the hot area. And then you focus your research, your fundamental research around those hotspots. There's a whole list of areas of materials that have been developed in this program. We're working with them basically on lightweight alloys, high entropy alloys, and phase change alloys. That's part of the Australian collaboration to this program as well. Part of this program is something called additive manufacturing. It's been discussed quite a lot in India, I know, and I know at least one company is investing in it. But again, this is the whole idea of why do you go and cast a large amount of metal, shape it, bash it, form it, heat treat it, bash it again, heat treat it a few more times, and finally finish up with machine it and finish up with some small component. Why don't you start with a metal powder and a laser or an electron beam and build up the shape as you go? And so this is really, again, one of these areas which is really changing manufacturing. It will take a fair while to come through, but it's estimated that the value of this will be $100 to $200 billion per annum by the year 2025. So it is a major game-changing technology. The way the Europeans are doing this, of course, if I was a bit in red, is that they form these very large consortia projects. And again, I think that's one of the challenges in India, is how do you go to building consortia or doing pre-competitive research rather than focusing on narrow one-to-one type relationships. So there are 31 partners in this program. So the investment risk is being spread, the outputs are much higher, and so the impact is much greater as well. The US has the Materials Genome Project, which is a similar sort of thing, but it goes based more around advanced materials, so I won't go through that. But again, this idea of rapid screening, rapid development of new materials. China is much harder to work out. I go to China quite a lot. And I know in India, China is discussed almost at every conference I go to now about what they're doing. We know how much they spend on R&D, but how they're targeted is quite different. And I think that one of the key things I want to say about this is that they're really changing their way they fund research in China. In the last 2 years, there's been major changes which we won't see for another 5 years. But massive investments, and incredibly what's happening now is those yuans are flowing out of China. They're cherry-picking in the West for technologies. They've also got a scheme where non-resident Chinese are attracted back to China. They're given a laboratory. They only have to be there for 1 month of the year. They're given a laboratory and full funding to support that laboratory over the whole year. I, in fact, have a laboratory in China with $1 million per year funding to do with whatever I want to do with it. So they're really trying to hunt the world for the best ideas in manufacturing. India has a fantastic opportunity. Like I said, I've been coming here for 10 years, and the more I come here, the more I'm convinced I am that the opportunities in India for manufacturing materials are phenomenal. You can see what's happening in ICT and what's happening now in biotechnology, and I think that the next real growth phase will be in the manufacturing sector and the materials sector that underpins that. You have a strong history of doing research in some really but really high-tech areas, the nuclear and aerospace, which is well known worldwide. At the other end of the spectrum with textiles and automotive, etc., the research is still at quite a low level. But the infrastructure in the universities is very strong in materials, whether it be in materials engineering or in physics or in chemistry or in mechanical engineering, because materials cuts across all these fields. And so there's fantastic opportunities, I think, to harness that. There's lots of, every time I come here, there's some discussion about the poor interaction between academic and industry. I do see changes. I think particularly in the IITs, there have been a number of efforts to try and grow cells where there is industry engagement. I think one of the challenges is what happens when you go outside of the IITs. It just drops away at a very rapid rate. And I think that one of the challenges is how do we get an R&D culture into the second-tier universities and colleges.
Peter, may I request you to conclude?
So what I would like to do is basically come to my final slide then. And what I would like to say is that materials really, as we've said quite a lot today with various talks, is materials do underpin nearly all the major things in society. The rate of innovation, though, is increasing, and so you can't go through the conventional, let's do a PhD in 3 years and hope that we get something out of it. There is a lot of rapid screening of materials, and that challenges our conventional view of excellence in R&D. I think India can play a major role in R&D and materials gap. The key gap to me is the human resource side, and I think that that's a real challenge to meet this opportunity. Limited venture capital is another issue, I think, here, where there's risk-taking in investment is quite low. And there's definitely too much red tape, having to try to set up some things in India that can be quite slow. But I'd like to say that, on a positive note, is saying that if we can create the right ecosystem, and I think it will involve international research partnerships with the US, Europe, and hopefully Australia, then I believe that India can be in the top group of nations in the next decade in materials research and its applications. Thank you.